Section 2.6 explains free body motions. Consider the question, in what ways can a body move in two-dimensional space? Refer to the figure below. The answer is that a body can undergo three different and independent types of motion, two of which are translational movements along the x and y axis, and one rotational change about a fixed point. Recall that a positive rotation is counterclockwise. It is best to think of the object rotating around a specified point, such as point Q in the diagram. Supports like the ones discussed in Lecture 2.5 are crucial for structures, whether individual or in a system. Individual structures refer to a singular object, while systems consist of multiple individual structures or parts. The importance of supports is because they provide counter-reactions to balance out forces acting on a structure, such as gravity. This ensures that the body always remains in equilibrium. You can refer to the tables below when following along with the examples in the upcoming slides. Before we move on to the examples, you may want to attempt the activity shown below. The required materials are 4 to 5 pieces of Lego or building blocks, or erasers, or any other small and rectangular objects. Lay one of these pieces on a flat surface, either standing up or on its side. This represents a singular structure. Stack the remaining pieces in any way you want. Observe if and how gravity affects the object. See if you can identify any counter-reactions taking place. An add-on activity would be to try and put a ruler on top of the individual object and then on the group of objects. Observe what adding other external forces does to both. Think about how you can position the objects so that the counter-reactions are stronger. This slide shows an overview of examples that address various types of supports and which allow the structure to be in equilibrium. For each scenario, consider the question which structures are sufficiently or completely supported. In other words, this means that there will be no movement in the x or y direction and no moments either. You may want to pause the video here to try them for yourself. In the next slides, we will be solving through each problem in greater detail. In this first example, the structure is supported in the vertical direction, so there is no movement in the y direction. As well, since it has two supports at two different locations, there will be no rotational movement either. The problem here is that because both the supports are rollers, there may be translational movement in the x-axis, so this structure is not fully in equilibrium. The second structure has roller supports that are perpendicular to each other, and therefore there is no movement in the x or y direction. Due to the three rollers at separate locations, there will also be no rotations, so this structure is deemed to be fully supported. The next example shows a structure that will not move in the x or y direction because of the pin support, and since there is also another roller support at the other end, it can also resist rotation. This structure is also sufficiently stable. The last example shows a structure with two rollers inclined at an angle. In this case, we must create a new coordinate system since the original coordinate system with the x and y axes does not match with this specific example. We will label the new axes with R and S, and it is shown here that the roller is supported along S, but not R. But since it is neither fully supported in the y direction nor the x direction, it does not resist movement along either axes, so therefore it is not fully supported.